Hello guys, welcome to our channel You Are Learning. So in this video we are going to discuss about the first important topic in design analysis and algorithm. So in this channel, if you are new to this channel, then subscribe our channel and click on bell icon to get notified by all the latest videos. So before going to the topic, let us know about what is an algorithm. So an algorithm is nothing but a step-by-step procedure for solving a computational problem. So if you see here, an algorithm is defined as a step-by-step procedure for solving a computational problem. So it states that an algorithm is a procedure which tells about the step-by-step procedure for solving a problem. So if you are taking a task, the steps required to solve the task is known to be an algorithm. So here another definition is given. Let us read it out. An algorithm is a finite set of instructions for solving a particular task. As above mentioned, it is a finite set of instructions. Like to perform a task, like taking an example, if you are if your mother is told you to go to a market and bring some of the essentials like groceries. So what would be the set of instructions there? Firstly, your mother told you to go to the market. It is the first instruction or first step, let us assume. And the second step is you are going to the market, and third step is you are buying all the essentials which you are ordered to go. Okay, next, the fourth step is you are stepping out back and going home. So it is the final step. So it is stated that an algorithm is a finite set of instructions for solving a particular task. Here, what is the task? The task is going to the market and bring the essentials. And how many steps are done here? Four steps. Okay, this is what an algorithm is defined. So again, next, characteristics of an algorithm. So there are five characteristics of an algorithm. First one is input. Input is nothing but the input which you are giving to solve an particular task. In the previous example, what would be the input? You are the input, right? Your mother told you to go to the market, so input here is you. And what would be the output? Getting the essentials from the market would be the output, right? Okay, next, finiteness is nothing but an algorithm should terminate in a finite set of steps. So we have to conclude the algorithm in a finite set of steps. Here, how many steps in the previous example has completed? Only in the four steps, so which is finite number of steps. And definiteness, each instruction should be clear and unambiguous. So in taking the previous example, the instructions of every step is clear, right? So there is no any doubt or ambiguity is nothing but like for single input different outputs are coming, then it is said to be ambiguity. Like your mother send you to the market, but you have gone to market and as well as temple. So that is ambiguity, right? So first, for single input different outputs are generated, so that is ambiguity. But an algorithm should be unambiguous. Like if you are ordered to go to the market, so you have to go to the market only, right? Are you getting? Okay, next, effectiveness. Effectiveness is nothing but algorithm should contain only the necessary steps required to solve a particular algorithm, right? A task should be performed with the necessary steps involved. Okay, this is what about algorithm. Okay, here let us discuss about the first topic in design analysis and algorithm, that is Towers of Hanoi. So in your examination you will be asked like uh, explain about the recursive equation of Towers of Hanoi, or else a question will be given and you have to solve the algorithm and prove the Towers of Hanoi. Let us see both of them right now. Okay, so first, taking t of n equals to 2 into t power n minus 1 plus 1, so it will be the first equation. Okay, so now so firstly t of n equals to 2 into t power n minus 1 plus 1, it will be the first equation. Okay, in second, in the next step, what we will do here, in the next step also the same formula, right? So 2 into t power n minus 1 plus 1, right? So here what will be the t of n? t of n will be the previous value, 2 into t power n minus 1. Minus 1 already exists. Minus 1 into minus 1 into minus 1 minus 2, right? Plus 1, and 2 into t power n plus 1, right? Are you getting? 2 into t power n will be the previous value, 2 into 2 into 2 t power n minus 2 plus 1 plus 1 will be the existing value, right? Again multiplying again with 2 into t power n minus 1. Here the updated t power n value is this one, right? So again similarly, so as solving this, you are getting 2 square t power n minus 2 plus 2 plus 1. Again multiplying it with 2 into t power n minus 1. Again same formula repeated for again, right? Are you getting? So again what we'll do, 2 square t power n minus 3 plus 1 and remaining value. Okay, are you getting? So it will be multiplied like this. Again we have to conclude the steps, like we have to multiply or do the t power n, t of n up to 4 values. So when we are getting 2 power 4, we will stop here, right? So next what we'll do, the actual formula will be placed like t of n equals to 2 power r plus t power n minus r plus 1 and so on. It will be the actual format of the Towers of Hanoi. Now t1 equals to 1, taking t1 equals to 1 and n minus r equals to 1, like n minus r equals to 1. So by this what we are getting, r equals to n minus 1. We will be concluded like r equals to n minus 1. Okay, now what we will do is t of n equals to 2 power n minus 1 into 2 tn minus n minus 1. We are substituting all these values here like in the previous value. Are you getting? So in this equation 1 we are substituting all these values like t1 equals to 1 and r equals to n minus 1. So what we will get, t of n equals to 2 power n minus 1, r value is n minus 1, t of n, r value is n minus 1, t of n minus n minus 1 plus t of n, r value is n minus 1. Already 1 is exist, so n minus 1 minus 1 plus and so on, 2 square plus 2 plus 1. Okay, now what we'll do, we will simplify this. Okay, let us assume t of n equals to x here. So here the t of n value will be the x. Let us assume, since t of n equals to x, what will get, x equals to all the previous value. Okay, t 2 power n minus 1, n minus n will be cancelled here, so the remaining value is 1 plus 2 power n minus 1 minus 1 will be minus 2 and so on, 2 cube plus 2 square plus 2 plus 1. Let it will be equation number 2. Now multiplying the above equation 2 with 2, like we are multiplying equation 2 with 2, what you are getting, 2x equals to all the value, previous value mentioned above, into 2. Okay, so it will be, as we simplify this, simplifying we will be getting right, 2x equals to all these values. Okay, now what we'll do, it will be the equation number 3. Let it will be the equation number 3. We have to minus this 2x minus x. Are you getting? Like equation 3 minus 2. Okay, then we are getting our final answer, t of n equals to 2 power n minus 1. It is the recursive equation for Towers of Hanoi. Okay, using this formula, t of n equals to 2 power n minus 1, using this formula we will solve the problem. Okay, now let us see that. So there are 3 nodes, 1, 2 and 3. So here the basic rules are nothing but we have to shift one node in one step at a time. Okay, one node should be moved or shifted to source or helping node or destination or helping node at once in a single step, and the order should be maintained, like the highest order should be in the base and proceeding to the lowest one. Okay, now in step 1 what we are doing is, let us taking three nodes. Here the n is 3, right? So three nodes, 1 2 and 3. And the helping node and destination node, here we are having these three. So in first step what you are doing is, we have to place we have to shift all these nodes into the destination in order to this, like we have to have the highest node in the basement and preceding to the basement node we have to place all the nodes. So first what we do is, we'll shift the third node into the destination as here given. We'll shift the third node into the destination, and in step 2 what we do is, we shift the second node into the helping node, like we are shifting the helping node, second node into the helping node. So in start step what we do is, here we have to empty the destination in order to place the highest value. The highest value here is 1, so we have to place the highest value 1 into the destination. In order to place 1 into the destination, it is not possible that smallest value in the above mentioned rules, it is not possible, like we cannot place highest value on a smallest value. Our main rule is nothing but, in this highest value we have to place the smallest value to the basement value. So the basement value should be high, and in order to basement value we have to place all the values. Okay, next. So in order to place like that, we have to empty the destination, so the destination should be emptied. So here the helping node is containing 2, so the 2 is biggest than 3, right? So we can shift the 3 into the 2. So here we have done that, we have shifted it to the helping node. So this is what the fourth step is. Now the destination is empty, so we will shift the 1 to destination. We have shifted the 1 to the destination. Are you getting? Next, here 1 is in the destination, but what we need is, we have needed the next node like 2. We need 2, right? But the highest the first value which have to come out is 3. So in order to do that, the source is empty, right? We shift the 3 into the source, like here mentioned. Next, the third step is nothing but, now the sixth step is, we will send the 2 to the destination, and the final step is source, helping and destination, that is 1 2 and 3. We shift source to the destination, which will be the final output for Towers of Hanoi. So thank you for watching, guys. Please subscribe to You Are Learning.